Okay, here we're going to do an MVP or most valuable problem type of factoring. And the short version is that we're just going to pull out the GCF, the greatest common factor, but it does look like a very, very complicated greatest common factor here. So one technique we could do is just a substitution, but I'm going to show you how to kind of jump from this to the end. So notice that we have a 4 and a 12 on the two separate pieces, right? View this as two separate things, quantities being added together, this object and this object. And what we're going to do is we're going to pull out the GCF. So what's the greatest common number that divides both into 4 and 12? That would be the number 4. Next, for the x's, we have 3 copies of x on the left and 2 copies on the right. And therefore we can pull out 2 of them. That'll be an x squared. Then as far as the x minus 8s go, we have x minus 8, and we have 4 of them on the left, 3 of them on the right. So I can pull out 3 that are in common. And with respect to the 2x minus 5s, we have 2 on the left and 3 on the right. So there's a total of 2 that can be pulled out. Okay, if that is my GCF, then the next part is to figure out what is left over when I pull that out. So I'm going to put a big bracket in order to signify that now I'm looking at what's left over. Say I pulled out from the first part, from this first initial part, I pulled out the 4. I pulled out 2 x's, even though there were 3, so I guess I have 1 left over. I pulled out 3 of the x minus 8s, but there's a total of 4 of them, so I do have another x minus 8 in here. And then I pulled out both of the 2x minus 5, so I guess that quantity's done. So now after the big red plus sign, I now have the second quantity left. What's left from over there is, well, let's see, 4 was pulled out and there was a 12. So there'll be a 3. I pulled out all of the x's because both the x squared or the x squared is pulled out. I pulled out all of the x minus 8s, but I do have 3 2x minus 5s as opposed to the 2 that I pulled out. So I am left with 1 copy of 2x minus 5. Okay, so that's what it looks like is left over. So now I can use some distributive properties and try to collect like terms and see if I can simplify this problem further. So let's distribute what's inside of here. And it looks like what I'll be left with is I do still have the 4x squared, an x minus 8 cubed, a 2x minus 5 squared. And then inside of the brackets, it looks like I have an x times an x, a minus 8 times x, the plus sign, 3 times 2x, and 3 times negative 5, or minus 3 times 5, so minus 15. Okay, now I can collect like terms. So I have 4x squared, x minus 8 cubed, 2x minus 5 squared, and x squared minus 8x plus 6x would be minus 2x, and then the minus 15. And so now the final step is to say, well, we still have this 4x squared. It's been hanging out here the entire time, right? X minus 8 cubed, 2x minus 5 squared. And then inside of those brackets, I actually have something I can break down into a product, right? Can you think of any numbers off the top of your head that multiply to be negative 15 and add up to be negative 2? Well, hopefully if you thought about it for a second there, we might think of x minus 5 and x plus 3, because negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So what has this accomplished for us now? This means that this answer that I'm boxing down here at the bottom is a product. It's a bunch of things being multiplied together as opposed to our original problem that had this plus sign in it. So this is the idea of factoring, and this particular problem, because it's so complicated, you might think of it as a most valuable problem in factoring.